Alrighty, welcome to the worksheet solutions for deriving natural log functions. In the top right hand corner, as you can see up here, I have the rule for differentiating natural log functions, which we're going to apply. The derivative of the inner side, or the inside of the log function divided by the original inside of the log function. Let's see some examples. So here we have dy dx equals, now the derivative of 4x, okay, here f dash x is just 4. So I get 4 divided by the original of 4x, and the 4 divided by 4 just equals 1. So I get 1 on x. Fairly straightforward. Now, question 2. There's 2 ways to do this. We could derive each of the logs individually and then simplify it where possible, or we can apply some log laws and combine these 2 logs first, which might be nicer. Now, because it's a product, it probably will be. So let's do that. So the first thing I'm going to write is y equals ln of x cubed times 3x. So that's one of our log laws, the product's log law. And that's going to simplify to y equals ln of 3x to the 4. And now we're going to derive that function instead. So the inside function here is 3x to the 4. The derivative of that, f dash x, will be 12x cubed. And so, therefore, dy dx for question 2 is going to be the derivative, 12x cubed, over the original, which was 3x to the power of 4. And as you can see, this can simplify now. 12 over 3 is 4, and x cubed divided by x to the power of 4 is just 1 on x. So it's just going to be 4 on x. Nice. Let's move on to question 3. We have y equals 4 times ln of x squared plus 4. So let's do the derivative here of this inside function. F dash x equals just 2x. And so we're going to get dy dx equals 4 lots of 2x over x squared plus 4. Now that 4 can distribute in and multiply by the 2x on the numerator. So we're going to get 8x over x squared plus 4. Done. Moving on, question 4. Now this one is going to take a bit more space. So I'm going to use the extra working space on the second side of this worksheet. If you're enjoying these videos and you're enjoying these worksheets, make sure you give the video a like. Helps out a lot. So y equals ln of 7x plus 4 all squared. Y equals ln of 7x plus 4 all squared. Okay, so I'm going to write over here, let u, this is my chain rule in action, let u equal 7x plus 4 all squared. Okay, therefore, that's going to mean I now rewrite this equation as y equals ln of u, which is going to derive nicely. So the derivative of y, but this time with respect to u, not x, is going to be 1 on u. Nice one. Now we have to derive this u function with respect to x. So du dx is equal to, now we could do the chain rule again, but hopefully we're getting to a point in our mathematics where we can do this sort of chain rule in our minds, where the order here, this 2, comes down the front, and we multiply by the derivative of the inside, which is just 7. So we're going to get 2 times 7 times 7x plus 4. Now, to the power of 1, because that power drops from 2 to 1. We just won't write that though. Let's simplify this a little bit. So we're going to get 14 outside of 7x plus 4. Okay, then we're going to have to distribute the 14 into both of these terms. Let's see here, 10 sevens are 70, 4 sevens are 28, so it's going to be 98x plus 2 14s are 28, doubled is 56. I think my mathematics serves me correctly. Hopefully it does. I'll just double check that. 70 and 28, yeah, 98. And 40 and 16, yeah, 98x plus 56. So that's du dx. So finally, I'm going to do this part in yellow, perhaps, the final answer. I'm going to say dy dx now is equal to, and I'll even style this original function so we've got all the same color coding here. It's going to be let's go with du dx so my red function off to the right, multiplied by my dy du, which is of course just 1 on u. So that's going to equal 98x, 98x plus 56. Keep that in brackets because it's the entire thing multiplied by 1 on u, which is going to be 1 on u here. Now 1 on u, I'm going to go ahead and write, no, I'll write 1 on u and we'll do an extra line, which is going to equal 98x plus 56. Now I've multiplied that by the 1. So this 98x plus 56 times by the 1 just goes to the numerator, all divided by the u variable here, which is 7x plus 4 all squared. So I'm going to write 7x plus 4 all squared, and that's my final answer. You could, if you wanted, expand the 7x plus 4 all squared, but I suspect it's not going to get us anywhere, so I'm going to leave it like this for now. And final question, which surprisingly won't take us as long as that one we just did, is going to be the derivative of this inside. So we get f dash x equals 4x cubed plus 4x. And that's it. The 7 just disappears. So 4x cubed plus 4x. So therefore dy dx is equal to 3 lots of 4x cubed plus 4x divided by x to the 4 plus 2x squared plus 7. Again, we'll distribute that 3 into the numerator. And so we get the derivative equals 12x cubed plus 12x squared. Just 12x divided by x to the 4 plus 2x squared plus 7. There we go. 5 questions done and dusted. Hope you liked that video. If you did, again, make sure you give it a like. Make sure you check out this video up here about differentiation of trigonometric functions. That's the next video in the series. Again, it's going to have a worksheet with it, so you make sure you head there, download the worksheet from the description, and I'll see you in the next one.